Assalamualaikum warahmatullahi ta'ala wabarakatuh. So today we're gonna present about sustainable brick from the article that we choose.
Okay, as for the introduction, for the first article is ceramic brick made from zeolite, pearl rock and sawdust. The article show that the use of zeolite pearl rock as an alternative and environmentally friendly building material, as well as the use of waste materials sawdust as pore forming agent, and its function in improving the thermal insulation and technical aspect of the ceramic brick produced. For the next article is bio brick using enzyme induced carbonate precipitation EICP and sodium alginate biopolymer. Based on the article, sodium alginate biopolymer and EICP procedure boost solution viscosity, increasing the cementing solution retention inside the treated soil, and potentially improving the treated soil significantly. The bio brick were supposed to have a better strength and durability thanks to the hybrid approach that combined EICP cementing solution with sodium alginate biopolymer. For the next one is the elliptic clay brick. Elliptic article said that elite is one of the most abundant clay material in the sediment and rock material in sediment and rock. A major constitution of many brick making clay. It's suitable for earth construction. Is and it can be determined by testing soil properties and comparing the result to the limit reference values and recommended values considered suitable for earth construction. Okay, that's it for the introduction. Okay, for the objective of the three article, first objective for ceramic brick made from zeolite pearl rock and sawdust is to investigate the utilization of zeolite pearl rock and sawdust to be an alternative for clay to produce new and eco-friendly brick. Next is bio brick using induced carbonate precipitation ICP and sodium alginate biopolymer. The objective of this test is to consider that bio brick can be used in construction industry. Elliptic clay brick. Elliptic clay brick purposely to consider whether elliptic clay brick is suitable for earth construction and compressive and flexural strength fall within recommended limit in earth construction standard. Okay, that is for the adjective. Okay, methodology for the ceramic brick. The ceramic brick get from the zeolite powder that was produced by quarrying and grinding process, and the sawdust was collected from the local resource as a waste material. After grinding by planetary ball milling, the powder particle substitution was obtained using sieve and hydrometer analysis. After that, it was analyzed by using thermal analysis, thermogravimetric analysis, and differential thermal analysis of the powder. To that, using the sintering method, which is a combination of pressure and heat to fuse particle into a single mass without melting the component. After that, the bulk density, open porosity, volume shrinkage, and water absorption was collected, and the data was collected data from this experiment. Okay, that's it for the. Okay, the methodology for the bio brick. The soft specimen in the cylindrical specimen was subjected to unconfined ceramic strength test in accordance with ASTM D 2166. The bio brick were tested using the compression machine with an axial strain rate of 0.5% per minute until the specimen failed. After that, the specimen was after that the wet and dry circle test was conducted to the specimen to determine the loose after the subjecting the bio brick to repeat the wetting drying circle. Next, water absorption test. This test is very important parameter when we need to evaluate the brick performance since the lower amount of water into the brick, the higher durability of the brick. After that, the freezing thawing circle test. This test was conducted by subjecting the half of bio brick specimen to 50 freezing thawing cycle or until they lost the 3% of their specimen, of their initial specimen. The efflorescence test is used to determine how salt and crystalline deposit form on the brick surface. After that, the dual needle heat pulse DNHP sensor manufactured by Decagon USA in USA was used to determine the bio brick thermal conductivity. Okay, that's it for the bio brick. Okay, next is the methodology for elliptic clay brick. Using the powder method, the mineral composition was analyzed by X-ray diffraction XRD. The loss of ignition was calculated at 450 and 1450 Celsius and 1000 Celsius based on weight loss to determine the carbon and carbonate content by thermal decomposition. To that, the mix design was conducted to establish the suitability of raw clay for earth construction and the effect of lime stabilization. Soil tests were conducted on various clay and lime mix. To that, the treat rolling method was conducted. This method was used to determine the plastic limit, while the next method is fall cone method was used for the liquid limit determination. A variant of the Proctor test was used to calculate the optimum moisture content. The flexural strength test and compressive strength was conducted to determine flexural strength followed by the compressive strength test. Okay, that's it.
Okay, for the result of ceramic brick, we have the particle size distributions of the use of raw materials. We have the XRD diffractogram of sawdust, XRD diffractogram of zeolite poor rock powder, and curves of natural zeolite and sawdust. After that, as you can see, we have the result of brick series and also the summary of fire bricks. This is the result for the bio bricks. We have the C main contents, the strain, and the flexural strains. So as you can see, we have the result of the elliptic clay bricks. So for the discussion of ceramic brick is zeolite poor rock from Tokac region, which is from Hungary, contains many minerals phases including montromorillonite, quartz, cristobalite, and calcite, as confirmed by SR measurement, which is in the result. And silica is the predominant oxide with a percentage of about 83%, followed by alumina as minor constituents. Then, for the thermal analysis of raw materials, a total weight loss of about 9.2% was achieved at 1000 Celsius. In the first step, 5.29% weight loss was recorded, which accounts for the free water's evaporation. The second weight loss is 1.74%, which could be assigned to the removal of the crystalline water and burnout of volatile organic matter. The final weight loss is 2.18%, which could be due to the continuous burning of the organic matter. Then, the discussion of biobricks is, through the result we observe that the presence of calcium ions with sodium alginate converts into a very higher molecular weight network compounds with a lower relative solubility that may help in binding the soil particles together. The efficiency was increased if compared with the past biobricks studies. The biobricks have a comparable performance to a cement-treated sand beams. These biobricks can be utilized in non-freezing climates for internal non-structural partitions, and walls made of biobricks may offer enhanced thermal isolation. And the discussion for elite clay bricks is hydraulics lime mix. Hydraulics reactions were expected to form cementing hydrates. The formation of a network of hydrates is often considered the reason for the increase in strength and thermal conductivity and the drop of water absorption. The result shows that stabilization of the elytic clay at low time contents can improve durability in liquid water. It lowers the strength and water vapor permeability and does not change the thermal properties. When comparing the properties of the fired and the unfired bricks, it can be seen that the thermal conductivities are comparable. However, the unfired brick is more permeable to vapor, which can improve indoor environment. It is evident that fired clay bricks are mechanically stronger and more resistant to moisture, frost, and salt damage than unfired clay bricks. So, for the conclusion of the ceramic brick, the conclusion that we can obtain is innovative and eco-friendly ceramic bricks were produced based on zeolite poor rock and sawdust using the unusual dry pressing technique. Sawdust was partially substituted by 2%, 4%, 6%, 8%, and 10% of zeolite poor rock. The conclusion for the biobricks is biobricks showed flexural strength that was comparable to 20% cement-treated sand. However, the biobricks did not have the requirements for salt attack and freeze resistance. This may suggest that these bricks are not suitable for the external walls and severe weather conditions. Other than that, they may be used only for the internal. Then, for the elite clay bricks, in conclusion, when compared the unfired brick with the fired brick, the strength and durability are lower. However, the vapor permeability is superior and the thermal conductivity was comparable. Therefore, the unfired elytic clay units can be used in certain applications where fired ones are currently used.
Recommendation. I recommend plastic waste brick. This brick was created using the plastic waste. It was made of waste material so it can help cleaning the environment. This brick is very strong and very light. So next recommendation is fly ash brick. This brick was created using a fly ash. This brick is lighter and stronger than clay brick. This brick is highly fire resistant. It's cheaper than other brick. This brick also can absorb more vibration than clay brick. The next recommendation is biomason brick. Biomason is a technology that uses microorganism to naturally harden the brick. So the carbon dioxide emission from this brick method is very low. This brick have great water resistant and fire resistant properties. Okay, that's it. My recommendation.